Obviously, with most robots, you're going to have some type of motor. That motor typically will not be able to be connected directly to your microcontroller. So what you need then is a motor controller that will sit between your motor and your motor controller, allowing you to control it. So that's what I want to take a look at today in this video, is how to use the Banebot motor controller with the Arduino to control a DC motor. So let me go ahead and begin here. Let me first explain the connections of the Banebot motor controller. So the Banebot motor controller has wires coming out of one side and the other side. So we're going to deal with this side first. There are two orange wires coming off of the one side, and there's no polarity associated with these. These are going to get connected to your DC motor. Obviously, being a DC motor, if you were to switch the connections, then the signal that you're going to be giving this Banebot motor controller would cause the motor to move in the opposite direction. So you'll need to try it one way, and if based on your program it's not doing what you want to do, you can either change it through the software or physically change your electrical connections. The other two connections are for the power for this motor. So if this is a 12 volt DC motor, then you need to have here a 12 volt supply. So those two leads then are color-coded red and black. So you're going to have a red and you're going to have a black lead. Obviously going to the negative and going to the positive end of your battery. Coming out of the other end of the Banebot motor controller is a fairly standard servo looking cable. So it's going to have 3 wires coming out of it. Now these are typically kept together, so these are part of a single cable, but I'm showing these as 3 separate ones. So one of these will be white, one of these will be red, and one of these will be black. The black one is going to be for your ground connection, so make sure that this is going back to all of your grounds. So you should be connecting all the grounds together, the battery ground, negative, this ground, the Arduino. So this is going back to the Arduino ground where all the other grounds are going as well. The red is typically not connected. And here's the reason for this. This Banebot motor controller has a battery eliminator circuit, a BEC, meaning that by applying this voltage that's powering the motor, it is going to produce a plus 5 volts for us, so that we would not need typically a battery to power our receiver if we're connecting this up to a remote control. You could use this. You could use this to power something, but we're already going to be powering our Arduino, so for us, we do not need this. So then that leaves the white. The white is going to go to a PWM port on your Arduino. So if you look at your specs for your particular Arduino board, you need to figure out which one can do PWM, pulse width modulation, and you'll need to plug it into one of those ports. So the connections are very, very simple. To program this then, we need to use the basic servo commands that we would use to control any servo motor. So that's what really makes this very nice. So with a typical servo motor, then we are going to have different pulse widths to make our motor to move different positions, or if it's a continuous modified servo that moves continuously, to make it move frontwards or backwards. So with this Banebot motor controller, the pulse width is going to vary from 1 millisecond to 2 milliseconds. If we were to give it a 1.5 millisecond pulse, that's going to cause our motor to stop. If we give it a 1 millisecond pulse, that is going to cause it to move in a particular direction, clockwise, counterclockwise. Again, it depends on the polarity of that connection, but at full speed in that particular direction. If we give it a 2 millisecond pulse, it'll move full speed, clockwise, counterclockwise, again opposite whatever this one is, but it will be moving at full speed. Other values will cause this to move at slower speeds in one direction, slower speeds in the other direction. Now that doesn't mean if you give it a value very close to 1.5 that it's going to be creeping very slowly. It's going to depend upon the torque of your motor. It's going to be dependent upon your mechanism and the weight and the mass and everything else. So you may have a dead zone here where you're giving it a pulse and it may not be moving. We have to have enough to overcome the mass of that motor and what's connected to it. So realizing that then, that we're going to be using servo type commands here, we would in our program first have to create a servo object. So you would use servo, and I'm just going to call mine DC motor. So this creates the servo object. I'm then going to go ahead, and this would be in the initialization part, declaration section, right before my void setup. So in my void setup then, I am going to need to attach that particular object. So I'm going to use my DC motor, and I need to attach it to a particular pin that's controlling it. So let's say in mine it's pin 3. So to control this then, in my void loop, I simply use the write microseconds to generate the pulse that I want. So if I want, then I could do full speed in a particular direction. That would be write microseconds 1000. But with this Banebot, there's a safety feature built in. With this Banebot controller, before it will accept any other commands, it must be receiving this middle neutral stop pulse. So that's going to be one of the first things you need to do. You may do it in the void setup, depends on your program and how you're doing it. I'm going to go ahead and put that in my loop. So I would say DC motor write microseconds and then my value in microseconds. So 1000 microseconds is going to be my 1 gave the wrong value there. I need to give it my 1500. So let me get my eraser. 1 second. And let's get rid of that. And let's go back and correct that. So that is my neutral pulse. my 1.5 millisecond pulse. And then you'd want to follow that with some type of delay. I'm going to put a 1 second delay. More than likely it could be less than that. The way you tell if this is working is when you run this, if it has received this signal and everything's okay, there's going to be a set of LEDs on your Banebot motor controller, and you'll see then that they will stop flashing and lock in. If they continue to flash, something's wrong with your program. So let's take a look then. If I've got my motor set up, I've got it wired correctly, I've programmed it over here, okay, I've given it my neutral pulse, how we move it to different positions. So we are going to keep on using that DC motor right microseconds. So we would continue. So let's put DC motor right microseconds. And this time let's put in that 1000. So that's going to give me my 1 millisecond pulse, and I can do other things in my program. Until this value changes, that Arduino is going to keep on sending that pulse. I don't need to have any loop to continue generating that pulse. So if I had a delay or I had other statements in here, that motor's can continue to go full speed in whatever direction. Again, that's going to depend on the wiring. So I'm just going to have a delay in here. And maybe I have a 2-second delay. Again, I could be doing other kinds of processing. I could be doing some things with sensors and getting values and manipulating those values, controlling other kinds of motors. That motor here is going to continue on moving at that direction and speed. If I want to change that direction, again, I use that same command. I simply have to give it a value corresponding to what I want it to do. And let's say I want something like 1.8 millisecond pulse. So now it'll move, but now it's going to change direction and not go full speed in another direction. If I would have given it a 2000, a 2 millisecond pulse, then it would be going full speed in the opposite direction, but I gave it something less. And so you would just continue with your program then, doing whenever you want to make the motor change and do something, use your right microseconds. If you need to make it stop, you're going to use a 1500 in here, because that's that neutral pulse. That's what's going to make it stop. All right, so I hope this was real helpful, and wish you luck in your endeavors in using this. If you've got any questions or comments, please post. Thank you.